Hello everybody and welcome back to another video on my channel. Today we will be talking about the power rule of integration in calculus. So I think that's pretty much about it, and let's move on to the video. Today we're going to be covering the power rule of integration, but also like 2 or 3 examples and a short proof that is very simple that proves this power rule is actually true. Now, this is an integration, so if you haven't watched the rest of my integration series, please make sure you do go watch it, as it's really enjoyable and fun to watch, and also teaches you a lot. And also, since you're learning integration right now, I also expect you to have knowledge of derivatives. So if you don't, then make sure you go and figure out knowledge of derivatives. So that's really about it, and let's get into what this rule actually is. So, this rule states that if I have an integral and then I have x to the n dx, the integral of this is equal to x to the n plus 1 divided by n plus 1 plus the integration constant c. And it's really that simple. Now, of course, all the integration rules apply. So if I have x to the n plus 3x to the m plus 8x to the z dx, of course you can split it all up into its separate integrals, etc. And if you have constants, this would be 3 times x to the m dx, and everything else also applies like definite integrals. So yeah, that's really about it for this rule. It's a very simple rule, but before we go into our examples, let's prove it. So our proof is that first, let's take this end result, x to the n plus 1 divided by n plus 1 plus c, and differentiate it. So this, if we do d by dx of x to the n plus 1 over n plus 1 plus c, we get the derivative of c is 0, so we get 1 over n plus 1 times the derivative of x to the n plus 1, which is n plus 1 multiplied by x to the n, and n plus 1 cancels out, so we have x to the n, and since differentiation and integration are opposites, this all checks out. Now, one final thing before we go on to this, what matters, you also know, is that n cannot be equal to -1. Anything else besides -1, as -1 essentially means that what you're saying is that when you differentiate it, you're going to have a divided by 0, and that's not very allowed, and that's not exactly good for when you're solving the integral, because you're not allowed to divide by 0. But in reality, if you do want to know what that is, x to the -1 dx, the integral of that is equal to the natural logarithm of x, but the proof of that will come in another video. So for now, let's move on and solve 2 different examples on how this works. Alright, so over here we have a very simple example. The integral of 3x squared plus 8x to the power of 4 minus 7x to the power of 5 dx. Now, if you already know this concept and are using this channel to find practice problems, or if you are just starting out but you feel like you want to tackle this problem on your own before looking at how I solve it, feel free to pause the video and try and solve it on your own. But for those who are staying here, feel free to stick along as I show you how to solve this problem. So, from the property of integrals that says if I have a sum of stuff within an integral, it's equal to the sum of the integrals. This equation becomes the integral of 3x squared dx plus the integral of 8x to the 4th dx minus the integral of 7x to the 5th dx. Now, removing all the constants gives us 3 times x squared dx. Then what we have is 8 integral x to the 4th dx minus 7 integral x to the 5th dx. Now, integrating all of these using the power rule, we get 3x to the 2 plus 1 over 2 plus 1 plus 8 times x to the 4 plus 1 over 4 plus 1 minus 7 times x to the 5 plus 1 over 5 plus 1. Now 2 plus 1 is equal to 3, so this cancels out. This becomes 5, and when we add all the powers, we get x cubed plus 8x to the 5 divided by 5 minus 7x to the 6th divided by 6 plus our integration constant c. So that's basically the answer to this problem, and as you can see, this was a very relatively simple problem compared to some of the other problems that I've seen so far and what we've done in the past. So there you go, that's your answer to the first problem, and now let's move on to our next problem. Over here we have our next problem, the integral from 1 to 2 of 3x squared minus 3 over x squared dx. So what we have over here is, first, since there's multiple stuff over here, and since we can factor out 3, we can do 3 multiplied by, and now when we separate the integrals, 1 to 2 of x squared dx minus the integral from 1 to 2 of 1 over x squared dx. Now, what many people didn't know is you can just have these integrals as 1 and integrate them with the same definite integral, so you don't have to rewrite this all the time. So this is not necessary or not always needed all the time. So let's switch to that, and let's make sure that we combine it all so it'll be slightly easier to integrate, especially with definite integrals. So when we integrate this using our power rule, we get 3 of x squared divided by 3 minus, now since 1 by x squared is x to the power of negative 2, that means we're going to have x to the power of negative 1 divided by negative 1. So x squared over 3 minus negative 1 over x. Now this is all from 1 to 2. And using techniques I discussed in my earlier videos, we get 3 multiplied by x squared by 3 plus 1 over x from 2. So 4 by 3, x cubed by 3. Why did I have x squared by 3? Sorry. We have 8 by 3 minus 1 by 2, plus 1 by 2, and then minus 1 by 3 plus 1. So now that we have that, we have 3 times 8 by 3 plus 1 by 2, or if we just expand it out, 8 by 3 minus 1 by 3 is 7 by 3, and then plus 1 by 2 minus 1 is minus 1 by 2. So what we have is 7 minus 3 over 2, or 11 over 2, and that is our final answer for our second problem for today. So that's really about it for our examples. If you enjoyed this video, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. And above all, if you found this video helpful or anything else and you'd like to comment it down below, please make sure you do, as I'll be able to help make my channel better for all of you. And that's really the biggest thing, is to help all of you learn about these topics that too many people think are not approachable at all. So, thank you so much for watching this video. See you in the next one, and bye-bye.